Students, in today's class we discuss very important naming reaction from aldehyde and ketone, that is aldol condensation. So students, first of all you see what is meant by aldol. Okay, just see here aldol. Okay, so here Al stand for aldehyde group and here Ol stand for alcoholic group. That means in this reaction two functional group is involved. One is aldehyde and another one is what? Alcohol. Okay, and condensation means there is a removal of water molecule. So students, just will see now in aldol condensation which aldehyde and ketone they undergoes this reaction. Okay, so aldol condensation, in this reaction only those aldehyde and ketones which carry the alpha hydrogen atom. Okay, what I say, aldehyde or ketone which carry the alpha hydrogen atom, only that aldehyde and ketone undergoes this reaction. Okay, so just see the students here. I am given one example, acetaldehyde, CH3 double bond OH. Okay, so what I say, the aldehyde or ketone which should contain the alpha hydrogen atom. So how we can see the alpha hydrogen atom? So this is the carbonyl group, students. So next to the carbonyl group we can see it is a alpha beta like this. So this is the alpha carbon, and in this alpha carbon how many alpha hydrogens are there? 3 alpha hydrogens. Okay, so that means acetaldehyde undergoes this reaction. Okay, so if you take the acetone, that also contains the alpha hydrogen atom, we can use acetone also. Okay students, so now we will see the aldol condensation reaction. So in this reaction, so here I am using the 2 acetaldehyde molecules. How many? 2. There, just see CH3 double bond OH, again CH3 double bond OH. So this reaction will carry in presence of dilute NaOH. Okay, so when we will react with dilute NaOH, so we will get a aldol. Just see, just I am given general reaction here, then we will see in details mechanism. So what happens in this reaction? So from the second molecule of aldehyde, so one hydrogen from this CH3 group is released and that is attached to this oxygen. So what remains now? CH2, and this whole group CH2 C double bond OH will attach to this carbon. Just see, CH3CHOH, CH2C double bond OH. So this is what aldol. Now clear students, how this aldol will get? So this is the first molecule of acetaldehyde and this is the second molecule of acetaldehyde. So from this second molecule, from this CH3 one hydrogen is attached to this oxygen. Now this convert into, when this CH2 C double bond will attack here, then what happens? This double bond will shift and now it convert into OH. So this is CH as it is, then CH2C double bond OH, CH2C double bond OH, it is nothing but aldol. So just see, in this aldol, both functional groups are there. C double bond OH, this is aldehyde, and OH, this is alcohol. That's why we can see it is a aldol. Now clear? So what is the IUPAC name? We can give the numbering from here. 1, 2, 3, 4. 4 carbons means it is a butane. So in that butane, third carbon carries a hydroxy group. We can say it is a 3-hydroxy-butanol. Aldehyde group is that we can say it is a 3-hydroxy-butanol, or we can say 3-hydroxy-butyraldehyde. That is a common name. Okay students, allow to understand up to this. Next thing, when aldol which on further heating, we just heat this. Okay, what happened now? So water molecule will remove. You can see it is a condensation that can remove the water molecule like this. So this OH and from this CH2 one hydrogen from this CH2 and this OH. What will remain? Here only CH group will remain. Here CH means double bond will come and this H2O molecule will remove, and here we get CH3 CH double bond CH C double bond OH. Just see, CH3 CH double bond CH C double bond OH. This is nothing but protonaldehyde. Now clear student, this is nothing but what? Protonaldehyde, and we can remove the water molecules. So this is the general reaction. Now we will discuss the mechanism of this aldol condensation reaction. So students, the mechanism of this reaction involves the 3 steps. The mechanism is very interesting. So first step is the formation of carbanion. Okay, so in see first, already in main reaction we can using the 2 aldehyde molecule. So in first step we can use first acetaldehyde molecule. So what happens students? Step first, just see here I am using the taken first molecule of this acetaldehyde, CH3C double bond OH, and this acetaldehyde reacts with base, or we are using here dilute NaOH, and that base they can give the OH minus ion. Okay, so they can give the OH minus ion. Now see students, in first molecule of this acetaldehyde molecule, So this from the CH3, so next to the this carbonyl group, next carbon, whatever hydrogen will be there, they are the more acidic in nature, and this is the base OH minus and the hydrogen which is a plus. So what happens now? This OH can abstract this acidic proton from this CH3. Now clear what I say? So this OH can abstract the acidic proton from this CH3. Now what happened here? Now one hydrogen will remove, then here CH2 will get CH2. C double bond O as it is, then H as it is. This OH and this one hydrogen water molecule will remove, and simply in step first here we will get a carbanion, and this carbanion is nothing but nucleophile. This carbanion here act as a nucleophile. Okay students, see the second step. In second step, whatever carbanion or nucleophile we generate, so that nucleophile will attack on carbonyl carbon of second molecule of acetaldehyde. So already we are using the 2-acetaldehyde molecule. So in step second I am taken the second molecule, CH3 C double bond OH. This is the second molecule of acetaldehyde. So whatever carbanion or nucleophile we generate in first step, that will attack on carbonyl carbon, because this is a minus charge and this carbon can be charged plus charge. Okay, so this carbanion or nucleophile will attack on this carbonyl carbon of second molecule of acetaldehyde. Then what happens students now? When this carbanion group will attack on this carbon, now this double bond will shift. Okay, oxygen can abstract the electron from this double bond, and now this oxygen converted into the minus charge, and this whole group CH2 C double bond group going to attach to this carbon. See here CH3, then this CH as it is. Now this double bond will shift, means O minus, and this CH2 C double bond OH. CH2 C double bond O H group, it is a intermediates. Now clear? So this is what intermediates. Now see the third step. In third step, same whatever intermediates will get in second step, that will take here CH3 CHO minus CH2 C double bond OH. Now this in step third it undergoes protonation. Protonation means it is a hydrolysis process. Okay, so we can add the H plus ion, and that H plus will coming from the water molecule obviously. Okay, so now what happened? So that intermediates will taken here, and this H plus will attack to this O minus. Now this O minus converts into the OH group. So what we will get now? CH3 CHOH CH2 C double bond OH. This is what aldol. So already in main reaction aldol will get, directly we will write this reaction, but in mechanism we will get like this. Okay, so all of you clear how we will get this aldol? So in 3 steps we will get this aldol. Now again this aldol, which on further heating, so it loses the water molecules. How water molecule loses, student? This OH group and one hydrogen from this H. Okay, so it can loses the H2O. Now what remain here? CH3 CH double bond CH C double bond OH. Then C is what? Protonaldehyde. Now clear students, how we will get a protonaldehyde? So this is the mechanism of Aldol condensation reaction. Once again I just revise this reaction. So this reaction in all the 3 steps. Okay, so first step is what? There is a formation of carbanion. First step is formation of carbanion. So in that we will using the first molecule, and that will react with nucleophile OH minus, and what we will get? We will get a carbanion. And in second step, so that whatever carbanion we will get in second step, that will react with second molecule of acetaldehyde, which will attack on carbonyl carbon. On this carbon will attack, and we will get here intermediates. And third step, same intermediates here I am using, and it undergoes protonation, and finally we will get here aldol, and that aldol again undergoes heating, which will get a protonaldehyde. So students, thank you so much for watching this video. So in next class we will discuss the Cannizzaro reaction.